Hi, everybody. My name is Neil McPherson. I'm part of Team Ant, Andrew Sitaro, myself, and Trey Hamilton. I'm here to today present our final project for DS6040. Our agenda will be to go over the introduction and the project goals, talk about how we use some Bayesian techniques in the process, discuss the results of our analysis, and some takeaways and improvements. We decided to look at the probability of a mortgage loan paying off in its early life, i.e. its first 24 months. Using some publicly available data sets from Freddie Mac on mortgages and mortgage rates, we wrangled some loan data, defined a classifier class, if you will, called is paid in 2 years, which is set to 1 or 0, depending on whether it paid off or not, and performed some EDA on the data set, which we'll discuss in a future slide. We used Bayesian model averaging and ultimately the lazy classifier to develop and test some models to predict whether, in fact, the loan would prepay early in its life by month 24. And in the process, we identified some of the key drivers of mortgage prepayments, both in terms of borrower and loan attributes, and considered some extensions later on to improve these models. The best classifier among the 25 models we tested in terms of accuracy turned out to be the LGBM classifier. And using this model improved the accuracy in our testing from a sample significantly from about 77% to 84%. A little background. Most mortgages in the United States are 30-year loans, i.e. you get a loan and you can in fact pay it off over 30 years, which of course drives the monthly payment down pretty significantly. And in the US, they're fixed rate. Generally, they can be adjustable, but most of the time, most people take a fixed rate loan, i.e. the loan rate you pay over time never changes. And the vast majority of them are in fact bundled into what we call MBS, or mortgage-backed securities, by two GSEs or government-sponsored enterprises, Fannie Mae and Freddie Mac. Understanding the prepayment rate of mortgage loans in these mortgage-backed securities and the drivers of prepayments, which are loan characteristics, economic factors like interest rates and home price appreciation, of course, economic activity, perhaps unemployment, and borrower behaviors also are well-known fields of study in fixed income research. And this is really because prepayment affects the speed of principal return for an investor, thus affecting the yield in a bond. We're not going to get into that discussion today, but it's a pretty interesting topic of analysis as well. In any case, our analysis here is vastly simplified, I should really point out, versus what would be used in the real world to trade or invest in these mortgage-backed securities. But the utility of our work, I think, is pretty valid, because knowing whether a borrower might prepay earlier in the life of the loan can be used to help, for example, optimize the profit and loss of loan origination, i.e. You want to have, if it costs, if you think a loan is going to prepay fairly soon in its life, you don't want to spend a lot of money originating it. It should be a low-cost loan origination. It also could help you identify some likely refinancing prospects, i.e. if you are in the business of mortgage lending, perhaps you can identify folks who might be all else equal, more likely to refinance sooner and approach them to perhaps get those new loan opportunities because you make fee income on those opportunities. And or you might be able to evaluate the cross-selling or relationship value, i.e. will this be a longer-term customer or not? Can I sell other products to this customer? Let's look at some of the data sets in the EDA. First, we used the Pandas profiling report, which I thought was a really nice way to kind of drop a data set in and get some automatic EDA done for you. And you can see some of the drivers we explored here follow a Gaussian distribution, namely the credit score, the DTI, the original unpaid balance, debt to income is the DTI there. Credit score is typically FICO or Experian score, and all else equal, some of these really affect how easy it is to get a mortgage loan in the first place, and of course, how easy it might be to get one down the road, right? So a higher credit score is a good thing. It's easy to get a loan generally when you have high credit. When you have a low debt to income, i.e. the payment is very manageable, it's easy to get a loan. When the high balance, when the loan is very high balance, these things, of course, that makes the loan payment high, right? So it's harder to make those payments. So in any case, you can see some of these are key drivers. The one on the bottom right is what we call RIV, arguably follows more of a Poisson distribution. And there, what we call that, it's an added feature we calculated rate incentive value, which tries to capture the duration and magnitude of an opportunity to refinance over the length of the life of the loan. Looking at the EDA of the various drivers of prepayment that we explored, you can see on the left-hand side, it's the full pairs plot. On the right, we exploded it a little bit. And you can see there's very little separation among the classes for a lot of these variables. And in fact, if you kind of go down the diagonal here, you can see in almost all cases, the yellow indicates, which is whether it's paid in 2 years or not, is almost always just subsumed by the by the overall pool, right? So you can see it should be a fairly difficult difficult class to predict. Again, we tried to capture refi incentive with a simple added feature. In this case, we called it RIV. We used in this analysis loans originated around 2010, so we'd have enough time to explore the life of these loans and how they paid. And we explored the difference in a falling rate environment here. So you can see in our analysis and in our sample, what we would expect to find would be some refinancing as rates fell in the early couple of years after 2010. And in fact, we did see that. Bayesian model averaging shows the key variables and the average coefficients. Among them, as you can see, the unpaid balance is a big one. RIV, our refinancing value, our interest rate, credit score, LTV, and DTI are all some of the drivers that were important. And you can see our average coefficients from Bayesian model averaging down on the right. And while only 24% of the overall sample did pay off in month 24, I thought was pretty high, just from my experience, we actually could predict them with pretty good accuracy. In our both predictive, using Bayesian model averaging and logistic regression, both had very good accuracy, about something like 77%, which I thought was pretty interesting, how we can predict these loans paying off, even though a relatively small portion do pay off. And finally, when you look at the lazy classifier suite of models, which I thought was a really nice addition to one of the homeworks, how you can basically drop your data sets in and kind of figure out, almost automatically, which of these various models will come up with the best accuracy. As it turned out, among the highest we found was using the LGBM classifier, and we did find an improvement over both logistic and Bayesian model averaging of something like 7% to obtain a more accurate result using very few features in my mind in this model, about 83% accuracy. So some of the key takeaways are that drivers of prepayment can be easily explored by Bayesian modeling techniques. In the analysis proceeding, we examined some of these drivers, and all else equal, higher balance, higher rate, better credit, lower DTI, and lower LTV, loan to value, all should be drivers of higher prepayments. Loan to value is how much loan do you have versus value. So typically that's about 80% for most borrowers, i.e. they borrow 80% of the value of their home, but all else equal, lower LTV means you have more equity and maybe you're better credit and easier to get a loan. Practice, one of our predictors, of course, RIV would need to be estimated because it's a forward look. In practice, you'd want to have it on a forward-looking basis to estimate whether or not something's going to prepay in 2 years, in the future. But in short to medium horizons, house price trends and rate forecasts out to 1 or 2 or 3 years are used pretty often. So I think they would be relatively easy to obtain. Somewhat counterintuitively, in our analysis, RIV was larger for some of the unpaid loans. But importantly, mean credit score was lower and DTI was higher. So these variables may have driven an inability to refinance in some of the unpaid loans. Finally, our analysis could be extended in a number of ways to explore the probability of a curve of loan prepayments, perhaps over n years, where n equals 2, 3, 4, out to 10 years, to kind of understand that probability, over time, and ultimately sampling other origination years. To get a broader sense of how different rate environments affect these models, and testing model accuracy in different environments would be an interesting analysis to extend as well. And finally, including perhaps a state level home price appreciation feature to see if our model predictively can enhance further, might be another way to improve predictability. And HPA is if your home price increases, then all else equal, again, it might increase the likelihood of you selling that home or refinancing down the road. So again, it could be an interesting feature to add as well. And all in all, we found the project to be pretty interesting. We learned a lot. I've operated in this world for quite a while. Working with my partners on this project, we found we validated our thinking on some of the key drivers, and importantly, kind of I think really reinforced our knowledge of the Bayesian model techniques. Thanks very much, and hope you enjoyed the presentation.